My name is Aiman Ifan. My CID is 15-4 and here is my group mates.
Hi, my name is Farah Lina binti Muhammad Izami. My CID number is 1510.
My name is Sivarat Subramaniam and my CID number is 15-29.
Good day to everyone. My name is Rafiq Hariri bin Zahiri and my class ID is 15-25.
Hi, my name is Chen Chuman and my CID is 15-6.
Project background is what we are talking about, what we are going to do, what is the background of the project, why are we doing this, okay. So since we are doing electrical scooter is a simplified vehicle that brings you from one place to another place, okay. So here we aim this project for students, basically students from the age of 15, 16 until university students. So students will actually have many ways to travel, like bus, cars, and etc. But then they can use another alternative, which is these electrical scooters. Why? Because it is very easy to use one thing with average speed, which can bring you from one place to another place within certain time. I mean, like faster lah. And then it's portable. It's easy to be stored and you can bring it anywhere. Next one is background studies and needs. Okay, background studies and needs means how is it previously and how have we improvised it with so many other things. Okay, so last time let's talk about scooters back in the days, back in 2000, 2008, 2009, 2007. Okay, those days there weren't any electrical scooters. Okay, that means you move the scooter with human power, which means you use your kick scooter. It was known as kick scooter. Now it's not kick scooter. We have made it powered by electrical energy. Okay, that means you don't need to kick the scooter in order to move the scooter. Okay, you just need to use the electrical power that is supplied to move the scooter. That's one. Okay, this is how we have improvised. Another thing, those days scooters, it was heavy. Heavy means very hard to bring it anywhere, very hard for you to like move lah, because if the weight increases, the speed will also decrease. And that means if the weight, if it's heavy, for you to kick the scooter for it to move faster is a bit more difficult compared to what you're going to do now. Now the scooter is light. Another thing that has been improvised now is it's foldable. Foldable in certain ways, where you can actually store them in a small bag and you can bring the bag anywhere. Just say if now you want to use the scooter, you can bring anywhere and use the scooter. Design brief consists of two statements, which is the problem statement and which is the design statement. Problem statement is whatever problems we are facing now to use the current existing scooter. So problem statement is existing scooters uses human energy to move and has very low portability. So the design statement is designing a foldable electrical scooter that doesn't require human force to move and good portability, which means it is easy to carry and store.
Product design specification. Okay, first is performance. Okay, performance, what we need in the scooter is it must be light, durable and easy to carry. Also, it needs to be foldable, has a good mobility, fast charging and using universal charger, and have one handbrake. The second one for the PDS is product size. What we need for scooter in product size is overall size of the scooter must be kept to minimum and it can be placed in bag and carried everywhere for use. And the third one for the PDS is product weight, and we need to keep the scooter as light as possible for easy to carry everywhere. Next, in PDS, we have materials. So materials of the scooter consist of metal and rubber, and it is reinforced to make product more durable, lighter and long lasting. Next is the product cost for the scooter can be cost up to Rm 1024 ringgit, including manufacturing costs and material costs for the scooter. Furthermore, in PDS, we have potential customer, which is the scooter is aimed for student mostly and suitable for high school, college and university students. The safety factor of the scooter is designed with non-sharp edges and corner, and in aesthetic, scooter should be presentable and captivating, and designed with minimum and no clumsy mechanism should be visible around the scooter. Next, in PDS, we have quantity, which is the production should be based on demand, Availability and accessibility of the product in each country. We continue with quality and reliability, which is the product should be tough and still functional even after collision. And finally, in ergonomics, for this slide, we have production design with suitable folding mechanism that will assist person to fold that product easily. Next, in PDS, we have testing, which is the product should have a model to test the quality and check any inability. Next, we have product lifespan, which is the product to last up to 5 to 7 years before a new innovation being introduced. And for life in service, the product should be able to be used for a long time without any damage. Next, in PDS, we have maintenance, which is the maintenance of the product should not be costly. For the time scale is, it takes 10 to 12 weeks left to complete the project. And for legislation is, it should obey, one of it is Consumer Protection Act 1999. Last but not least, in PDS, we have design constraints, and first is material, which is even the aluminium alloy is such a good product, but the cost for the material is quite expensive. And next is usage. The scooter cannot be used under extreme conditions such as flash flood or steep zone and other else. And that's the final of design constraint.
Let's talk about design function decomposition analysis. Okay, this basically tells you the parts of the scooter and what is it designed for, what is the use of the parts. Okay, so the foldable electrical scooter has few parts, which are the frames, brakes, regulators, handlebar, deck, battery, tire and motor. The uses for frame is designed for the scooter on how it looks. Okay, that means if it has 2 tires or 4 tires, as in like some aesthetic looks and stuff like that. Okay, so brake is, I think it's quite common in all the vehicles to slow down the vehicle. Regulator is something that controls the speed. That means it has a speed limit until 40 to 35 kilometers per hour. So you can control, like just say if you want to go slow within like 5 kilometers per hour, you can like control using the regulator. Handlebar is to steer and control the direction of the vehicle. Handlebar, which means you can turn left, turn right, go straight, stop, like for you to control basically. Okay, so the deck is where you place your legs on. That means where your stand is called the deck. Okay, used for a battery. It's a power supply for the scooter as the scooter is electrically powered. Tire is basically to move the scooter, and then it supports the scooter lah, supports our weight also, because that's where the weight will be exerted. And then motor is the performance for the scooter lah, which means it runs the tires as well. I mean rotates the wheels as well.
I will be presenting about the morphological chart of our group. Firstly, as we can see, there are 9 functions, each with a few options to choose from. Starting from the first function, which is the support of the scooter, or the overall design of how the scooter is going to look like. Each option differs from each other either by the number or the position of the tires. Option 1 and 4 have 2 tires, but option 1 has 2 tires on the front, while option 4 has 2 tires on the back. Option 2 and 3 have 2 tires, but the design of the option 3 looks more like a fusion of a scooter and a bicycle. Moving on to the next function, which is to slow down and stop. There are a total of 3 options to choose from. Firstly is by using our foot. A shock absorber, which is placed at the top of the back tires, will be stepped on to either slow down or stop the scooter. A disc brake or drum brake will be placed at the tire, and we can use it to control by a handbrake at the handlebar. Next is to monitor speed of the scooter. We choose to use either a throttle or by a phone for our scooter. The throttle will have a digital display of the speed of the scooter. As for the phone, we can connect the phone to the scooter to have a real-time display of the scooter speed. To steer the scooter, we have come up with 4 options to go with. We have the BMX handlebar, batwing style bar, a T-handlebar, and a wire handlebar, as we can see from the table, each with their own unique shape and will affect the efficiency of steering the scooter. We also included the function to rest our leg while using the scooter, which is basically the deck of the scooter. The type materials used on the deck will affect the overall weight of the scooter, since it covers the most part of the scooter. The materials that we chose for the deck are metal, aluminium alloy, wooden, and titanium. The source of power for the scooter will either be lithium-ion, lead acid, nickel metal hydride, and lithium polymer. Each power source will provide the power needed to move the scooter. The one with the most efficient one will be chosen for our scooter. So the next function is to move the scooter, which is the type of tires that will be used. We have 4 options to go with, starting from the off-road tire, which is suitable for all type of terrain, the tubeless tire, which is an air-packed tire, a honeycomb tire, and lastly solid tire, which is in contrast to tubeless tire, it does not have air inside it. Since we're designing a foldable scooter, we have a few options to fold the scooter. The first option being a simple push button to fold, a lock lever system, a kick and fold mechanism, and ring control system. The option with the easiest and the most user-friendly option will be implemented on our scooter. Lastly, an energy converter to convert electrical energy from the power source to kinetic energy to make the scooter move. We have either brushless DC motor, a brush DC motor, and a hub drive motor.
The screening matrix is a filtering stage to choose some best design among all the products. For electric scooter, the required selection criteria are durability, waterproof, easy to carry, easy to hold, fast charging, brake, product lifespan, speed monitoring, stability, motor, tire, and type of fender, a total of 12 criteria. In our case, the screening matrix is carried out twice to choose 3 best designs to proceed to the next stage, which is scoring matrix. For the first screening matrix, there are 14 designs to be filtered, and design 3 is the datum for the reference in filtering the electric scooter. As a result, designs 9 and 14 are qualified directly to the second screening matrix. Design 2 will combine with Design 15, 3 with 6, 7 with 13, and 11 with 12. Besides, Design 4 is revised to be a better design. So for second screening matrix, there are 8 designs to be filtered, including Design 3, which is the datum. And for the result, designs 7 with 13, 11 with 12, and 9 are the 3 designs to be chosen into the next stage.
After we have done the screening metric, the last process is the scoring metric. The purpose for doing this process is to know which one will be our final design. The concept scoring is used to increase resolution and better differentiation among the competing concepts. Then, in the table, must have the selection metric, criteria, and the weights. How to do it? Firstly, rate the concepts using the rating system. Our datum is our reference. As you can see on the rating system, first one is the much worse, second is the worst, third is same, fourth is better, 5 much better. Then rank the concept by multiplying each weight by weight. The total weight is 100%. After that, sum each design to get the total score. Lastly, rank the concept on basis of the highest sum. As you can see on the table, the concept design of 11 and 12 is getting the highest sum. In addition, the content of the criteria for this process is just the same with the screening metric, not changing at all. Moreover, here are some new designs that we got after we do the screening metrics. The first one is the combination of 3 and 6. The second one is the combination of 7 and 13. The third one is the combination of 2 and 15. The fourth one is combination of 11 and 12. Not only that, we also have the revise of the design number 4, which will improve the materials and other parts. So in conclusion, there are some steps before we get the final product. So the first one is do the product design specification, construct the morphological chart, do the screening and scoring metric. Each process are dependent on each other. So if we don't do the product design specification, we can't do the morphological chart and the rest. So it is depend on each other. As we can see, product design specification is the most important thing because it is the guideline before we get the final product of our scooter. So that's all from our group. Thank you for watching.